So you guys are finally on to triple integrals. Yes, it sounds difficult, and hopefully by now you've learned about double integrals. But triple integrals, don't worry about it. It's quite literally. I'm going to be exactly as a person that is taking Calculus 3 right now. Triple integrals was like the same difficulty as double integrals, but you just can't visualize what you're integrating necessarily. And there's going to be a lot more coordinate systems that you can use. But a triple integral will just look something like this. You'll see three integrals, and you'll see a region, and you're going to be you're going to have some function of x, f, and z, and you're going to be integrating over a volume now. So previously, in a double integral, you would have some function, let's say f of xy. And this function was, I don't know, x squared plus y squared, a paraboloid, starting at the origin. You could then integrate on maybe like a square, and then your output of this double integral would be a volume. Now that's not the case for a triple integral, and honestly I don't know what the name is for what you get outside of it, because then at this point your answer will be, I guess, say four-dimensional. So no way, human brain cannot picture that. Don't even try to picture it. But you can picture the location that you're integrating over. So in double integrals, you're going to have a dA, and you can draw out the area you're integrating over like a square rectangle. And I actually drew that out. Now in the case of triple integrals, you can do that too. Let's try to draw this out right now. I'll try my best to draw a 3D graph. Okay, and then I'll draw like, I don't know, like a square here. Square. So I'm trying to draw a cube right now. Oh, I can dotted lines. Okay, close enough. This is a cube. This is supposed to be a rectangular prism. So for this, the length of this rectangular prism, this is the, let's label the x, y, and z axes. So the x value is 5. The y value, and actually let's write out the points. This point is 5, should be 5, 5, 3, 0. So 0 is the z value. This point is 5, 0, 0. This point is 0, 3, 0. And this point right here, let's change the color for that. This point here is, I don't know, 5, 3, 3. So basically this cube has just a height of 3. Notice how the z value is 3 here on this blue point. Has a length of 3. So length of 3, because the y value max is 3, and a width of 5, because the max value for x is 5. So what can you do here? Well, if you want to integrate or take a triple integral of some function over a cube, I mean a rectangular prism like this, all you have to do is just integrate over your region. So set this up, and I don't know, let's just say our function is, I don't know, x squared plus y squared plus z squared, something very simple. You would set up your triple integral like this: x squared plus y squared plus z squared. Notice how this is our function of x, y, and z. And you would do dz, dy, and dx. The order of integration does not matter. Remember that. The order of integration does not matter. You'll get the same answer no matter what. But some orders are easier than others, so keep that in mind. But for this example, we can integrate with respect to z, with respect to y, and with respect to x in that order. So what are our z bounds? Well, the z bounds for this is just the height from 0 to 3. Right? So we just write 0 to 3. How about our length? Our max y value is 0 to 3, because y's greatest value for this rectangular prism is 3. And our x bounds are from 0 to 5. There you go. It's that easy. But if this rectangular prism, let's just cover that real quick. If this rectangular prism stretched into, let's say, the -1, it's very bad drawing, but the -1 axis, I mean that's -1y, matter of fact, then your bounds would just simply be -1, 3. So setting up the triple integral is just marking the region of your coordinates in your plane that you're using, or in the coordinate system that you're using. In this example, we are using XYZ coordinates. And later on, you're going to learn about spherical and cylindrical coordinates, because if you want to, let's say, integrate, you do triple integral of a cylinder or a sphere, you can. It's a lot more difficult to use x, y, and z coordinates. One last thing. Actually, not one last thing. Yeah, this should be somewhere near the last. But when you do triple integral and the question is asking you to find the area, I mean the volume, your function is just equal to 1. And you can just set the integral like this. So your integrand in this case is 1, and your integrand is your function. So you can actually, if you use spherical coordinates, which you'll learn later, you can actually, or let's use XYZ coordinates. If you use XYZ coordinates, you can actually find the volume of a rectangle by just setting the integrand to 1. Which sounds weird, right? You usually find a volume with double integrals, but with double integrals, if the question asks you to solve for an area, the area of some shape, you would just set your integrand to 1 as well. So if you want to find area using double integral, set your integrand to 1. If you want to find a volume using triple integrals, set your integrand to 1 as well. And one last thing, this quick side note, triple integrals, the hardest part is just setting them up. Once you do everything, it's just calculus. So if you have any questions, put it down in the comment section.